Welcome for this event in the context of the EU-China Blue Year on forecasting data, monitoring, planning and indicators. We have really a very significant number of shared interests with regard to oceans between the European Union and China. And these cover really the whole gamut of policies that we each cover, whether it's governance, it's environment and climate change, or the blue economy. And this afternoon is really about all the concrete things that we do with regard to data and the best ways in which we can exchange on these particular topics. So my job is simply to introduce this and give the floor to the two political speakers at the outset. Before I do so, just a quick logistical remark. We have interpretation in Chinese and English. Chinese is number 24 on your channel selector right here, and English is number 2 on your channel selector. So, without further ado, it's now my honor to introduce Commissioner Vella, who is the Commissioner for Environment, Maritime Policy and Fisheries. Commissioner, you have the floor.
Thank you very much, Administrator Wang, colleagues and ladies and gentlemen. A very good afternoon to all. And I have to say that I am delighted to welcome all of you to the very first EU-China Blue Year event, especially those who traveled all the way from China. Administrator Wang, it is a pleasure to see you again, only a few months since we last met at the EU-China High-Level Dialogue on Ocean Affairs. The fact that we have managed to assemble such a distinguished set of participants at such short notice shows how important this event is, and it shows the enthusiasm to get started straight away, because everyone wants better data. I was recently talking to a group of major investors, including the World Bank, the European Investment Bank, and a number of other private banks. I asked them what we could do to increase investment in the blue economy. They all said that they understood the potential, but it was unfamiliar territory. Before putting more of their money in, they needed better information on the resources, living and non-living, and on the risks from tsunamis, storm surges, new diseases, sea level rise. We have realized this for some time, and delivering this information has been a priority. For a long time, one major factor holding us back was the large number of organizations holding the data. As a result, our marine and maritime industries had to spend huge amounts of time and effort finding out who held the data, negotiating access to the data, and then putting together data with different standards, baselines, and formats. So we have put a major effort into bringing together all the European institutes who hold data. This is now bearing fruit. We have been collecting structured information on fisheries since 2004. EU satellites are regularly providing information on the temperature of the water surface. We now have a digital map of the topography, geology, and habitats of the seafloor. We still have some way to go, but we are making progress. And it is not only about data. We need to understand how to put together this information to forecast how a changing climate and changing human activities will change our seas. For example, we can measure the plastic in the ocean. But if we are going to reduce it, we need to work out where it is coming from. And as the blue economy grows, there is more and more demand for marine space. Wind farms now occupy significant areas in our shallow northern seas. Already, as many people work in offshore renewable energy as are engaged in fishing. Like you, We are developing spatial plans governing which activities can take place in our seas. So we need to know how one activity affects another. We need to be reassured that biodiversity will be maintained for the benefit of future generations. We know that China has been working on similar issues, and I realize that there is already good collaboration. Scientists are generally more advanced than politicians in working together. They see the advantages of cooperation immediately. We can build on this. This meeting will be an opportunity for us to look at each other's programs, to see what lessons have been learned, and to see if we can make better use of our investments by working together even more closely. Our combined investments in monitoring and data make up a good proportion of the global total. If the European Union and China can find common ground, then others will follow. On that note, I wish you a very successful meeting. Thank you very much. Thank you.
Thank you very much, Commissioner. I now have the pleasure to add my welcome to yours for the Administrator of the State Ocean Administration, Dr. Wang Hong, and his delegation, and to give the floor to Dr. Wang for his opening statement. Dr. Wang, you have the floor.
Thank you very much, Mr. Chair. 尊敬的
Your Excellencies, Mr. Villa, Mr. Kalavata, ladies and gentlemen, good afternoon. Just now, Mr. Commissioner, you've mentioned that this year marks the opening of the China-EU Blue Year, and in fact next year, tomorrow, the leaders from both parties will actually launch this event officially. This event today is actually marking the opening of this special event, and hereby, on behalf of my organization, I would like to extend our sincere congratulations on the successful convening of this event, and thank you all to our EU colleagues for your hard work and input. We know that ocean data report and monitoring is an important public service provided to the general public, and the Chinese government attached great importance to forecasting data, monitoring, etc. And my organization has been working very hard on this specific area. After 4 decades of effort, our capacity building in this area has been improved dramatically. For instance, in the ocean monitoring, we have vessel-based monitoring, we have shore-based monitoring, satellite, remote sensor-based observation. We also have seabed operation and also buoys observation. We have 3 national level report center and provisional report center, and then also the grassroots report center. So it's a complete observation network. In terms of data forecasting, we have set up database for oil spill, for tsunami, for extreme weather conditions, and many other items. We also have a regular reports on El Nino and other extreme weather conditions, and we also have medium and long-term weather condition report. So we've also invested a lot in, for instance, natural disasters prevention and forecasting. We also have made progress in laws and regulation in terms of ocean forecasting and disaster prevention. Ladies and gentlemen, to improve the capacity of ocean data forecasting and monitoring, we cannot live without international cooperation. We've been working very closely with IMO and other international organizations and have bilateral cooperation with many countries, for instance, with the EU, with Germany, with France, with Italy, and with Belgium. We've established operational level cooperation with these institutions and have carried out practical cooperations as well to enhance bilateral cooperation between China and the EU, in particular under the guidance of the China-EU Blue Year, to better the cooperation between the two sides in ocean data monitoring and forecasting. I'd like to provide the following observations. Number one, we would like to carry out global observations, ocean observations jointly, in particular prioritize those key regional areas, key ocean areas, to make sure that the data will be achieved sustainably and accurately. The second area will be to have a joint R&D on key technology, in particular in terms of data assimilation. We'd like to have partnership to have a stable and long-term cooperation scheme. We also would like to see that both parties could work closer together on ocean biology. The next area would be on research on climate change and how we could monitor the effect of climate change on ocean ecology. We could perhaps invest more in this area. Number four, forecasting and report on the polar areas. We know that the year 2017 and 19 will be the North Polar report and monitoring project, and we'd like to use it as a platform to extend our cooperation in this area. So all in all, I'd like to encourage all parties to exchange opinions on this platform, and I wish this event a great success. Thank you very much.
Very much, Administrator Wang. And I think that we are now slowly but certainly going to gear up for starting the first session of the afternoon. I understand that you both have to leave, unfortunately, so you can't stay with us. Maybe we'll give you a couple of minutes to leave, and then we can start the working session this afternoon.
Thank you very much.
And thank you very much.
Thank you very much.
Thank you very much. It was very nice to meet you again. All right. Okay. So I think that you've seen the agenda. We have two sessions for this afternoon. One on EU systems and one to describe the Chinese systems for marine forecasting. But before we start on the first session, and since this is a fairly small group, I wonder whether it would be okay to just go around the table quickly so that everybody can introduce themselves. I know that you probably all know each other anyway. I mean, I've seen a number of warm handshakes before the meeting started. But I think it might be useful if we do first a round of introductions to kind of break the ice, and then we kick off with the first presentation in our first session this afternoon. And if that's okay, we can start maybe at this end and then go around the table this way whilst Ian is still working to get the presentation on screen. All right? Okay, let's start.
Good afternoon. My name is Günther Hörmandinger. I work for the Directorate General for Environment in the European Commission in the unit that deals with the marine environment and some other issues.
Good afternoon. My name is Serge Scurry. I'm working with the Royal Belgian Institute of Natural Sciences, which is just behind this building. I'm head of the Belgian Marine Data Center and Belgian delegate to the IODE program of the IOC. And I am also involved in two major European initiatives concerning marine data, namely EMODNet and Sea Data Net, Sea Data Cloud infrastructure.
My name is António Pinho. I am from the permanent representation of Portugal to the EU. I follow fisheries, oceans, integrated maritime policy, and forests. Thank you.
Hi, my name is Stephen Hines. I'm from the Socioeconomic Marine Research Unit in the National University of Ireland, Galway. We are responsible for putting together ocean economy statistics for Ireland, which is the main piece of work we do of interest to this group, I think. Thank you.
Hello, my name is Venetia.
各位下午好，我叫 Blue， 我来自于 DG Mari， 就是海洋总司，负责渔业的数据框架和数据统计的。
Hello everybody, my name is Stefan Izoar. I'm working at the European Environment Agency in Copenhagen, Denmark. I'm head of group for water and marine activities.
Good afternoon, George Triantafylou from the Hellenic Center of Marine Research, mainly responsible on the forecast and recently involved in the prediction of microliter and microliter.
Good afternoon, my name is Richard Gilmore. I'm from the European Commission working with DG GROW in the unit which is responsible for the management of the Copernicus program.
Good afternoon, I'm Cecilia Donati. I work for Mercator Ocean and we are entrusted by the European Union to implement the Copernicus Marine Service on behalf of the Union.
Hello, I'm Fabienne Jacques from the European Commission, DG GROW, working on the Copernicus Marine Service.
Thank you. Hello, I'm Gui Mei Liu from National Marine Environmental Forecasting Center, Beijing, China. I'm working on a coastal circulation model to do the forecast for the temperature, salinity, and also water current. In fact, and also right now we are trying to exploring the ecosystem forecasting. And also in our division, we also do some search and rescue, OSBO, and such so on. Okay, thank you.
Good afternoon, ladies and gentlemen. My name is Li Rui from North China Sea Marine Forecasting Center. My major work is to focus the regional waves, storm surge, and sea ice, and also concern about the applications of our focus products and observation data. Thank you.
Good afternoon. I am from from the North Sea Division of the State Oceanic Administration. My name is Dou Yueming, and I am responsible for submarine technology, the disaster prevention and relief.
From the National Marine Environment Monitoring Center, State Ocean Administration, China. My background is marine chemistry. In our institute, I'm responsible for the marine pollution monitoring and assessment methodology. In our delegation, I'm responsible for the marine debris. Tomorrow I will have a talk about this issue. Thank you.
Good afternoon. My name is Lu Wenhai. I come from National Marine Data and Information Service, China. I'm majoring in marine economy. Thank you.
Good afternoon. My name is Rasmus Nielsen. I'm from the Technical University of Denmark and a professor in fisheries management, and I'm responsible for end-to-end ecosystem modeling and bioeconomic fisheries modeling at that institute.
Jun Shi from Danish Meteorological Institute. I've been working on operational oceanography and also recently on the EMODNet checkpoint projects, mainly working for the European regional seas. Thank you.
Good afternoon. My name is Lodewijk Abspoel from the Netherlands, the small country partially below the water. I'm involved in integrated maritime policy from the range of the ecosystem to the blue economy.
Good afternoon. I am from NMEFCSOA. My name is Wang Hui. My center is in charge of the marine forecast from the sea to coastal forecast and related services. My center, just like Mr. Wang said, it works with our European partners, such as the Italian, French, Danish, and Norwegian partners. We work with all these national centers. So this is a rare opportunity for us to have face-to-face communication. I hope we can continue our cooperation in forecast. Thank you. Good afternoon. My name is Xiang Wenxi. I am from NMDS, also a division of State Oceanic Administration. My center is in charge of the plastics in the sea, the information system building, and the research of spatial planning and blue economy, as well as the research on the environment, on the environmental protection of the sea, the islands, and etc. I'm very pleased to meet all of you, and I look forward to our cooperation. Thank you.
Gina McMill, I work at the Secretariat of EMODNet with my colleague Jan Bart, who will introduce EMODNet shortly.
I'm Ian Shepherd. I work for the European Commission, Directorate General Maritime Affairs and Fisheries, and I'm delighted to see so many people here and look forward very much to the presentation.
Good afternoon. My name is Jan Bart Kallewaert. I'm coordinating the efforts of the Secretariat of EMODNet together with Una, and we do that to support DG Mare and the European Commission with administering the network. And I will tell you all about it in a few minutes.
Good afternoon, everybody. I'm Giovanni Coppini. I come from the Euro-Mediterranean Center on Climate Change in Italy. I'm coordinating the Mediterranean forecasting system as part of the Copernicus Marine Service. As well, I'm co-chairing the GOOS Regional Alliance in the Mediterranean. I'm here also because Italy has signed some years ago an agreement with the National Marine Environment Forecasting Center in China. So every year we meet, we visit each other, and we have a common strategy plan. So I'm very happy of this meeting. Looking forward to your presentations.
Okay, and I just realized I forgot to introduce myself. So my name is Heitze Siemers. I'm head of unit for maritime innovation, investments and research, and my unit also deals with the maritime policy aspects of climate change and the marine environment in close coordination with our colleagues from DG Environment. And very happy to see you all here, and I'm really looking forward to hearing more about what both sides are doing on marine observation. So let's kick off with the first presentation by Jan Bart Kallewaert on EMODNet. You have the floor.
Thank you. Once again, thank you very much also, and it's a great pleasure to be here and to meet all of you, which is quite a unique event, I think, today. And it's always a great pleasure to speak about EMODNet and the efforts that we are doing in Europe to make the wealth of marine observations and data more available to the users. But before I do, and I will give you a bit of an overview of what EMODNet is all about, I would like to take a step back and say a few words about the policy context and framework, because that's important. And that brings us to Blue Growth, which is the European Union's initiative to try and reap the potential of the seas and oceans to create jobs, value, and sustainability. And in the work that DG Mare has done in the past, we've identified a number of growth sectors which show a high potential for for such growth, which includes blue tourism, blue energy, aquaculture, blue biotechnology, and the exploitation of marine mineral resources. These are in addition to the more traditional sectors, such as shipbuilding, transport, and fisheries. But what is important is that all of these sectors, what they have in common is that they all heavily rely on the timely delivery and access to high-quality data, information, and knowledge about the marine environment for all of their stages of their activities, from planning, preparation, exploration, up to their operation. But let's be very clear, there cannot be any marine knowledge generation without first collecting the data and observing our seas and oceans. And that comes at a very high cost. And what is perhaps maybe a bit unique in Europe compared to other regions is that the large majority of this cost is carried by the member states through various mechanisms, also by the European Union and sometimes at the regional level. And as a result, there is quite a strong level of fragmentation, both at the level of the ocean observation side, data acquisition side, and at the side of the data management and provision of access to the resulting data and observations. Now, I'm not going to speak too much on the data acquisition side of things, because that's something that's being dealt with by a number of organizations through a process that is working towards the establishment of what we will call European Ocean Observing System. And I will focus more on what we are trying to do to tackle the fragmentation on the data access side. So to deal with this problem, the European Union has, through DG Mare, developed the Marine Knowledge 2020 strategy, which is trying to convert the fragmented landscape and deliver a interoperable marine data sharing framework, which is based on the principle that data is collected once and then reused for as many purposes as possible. That comes with a vision target to deliver a seamless multi-resolution digital seabed map of European waters by 2020, covering topography, geology, habitats, and ecosystems, and providing the highest resolution possible where it is available. And in fact, this is already what we provide. All of that should be accompanied by timely information on the physical, chemical, and biological state of the water column. It should be easily accessible, interoperable, and free of restrictions on use. And EMODnet is central to delivering this vision target. It consists of about 150 different organizations in Europe that are working together to assemble, harmonize, and make available data, metadata, data products, and data services. And it is organized through 7 themes or disciplines, covering geology, data on biology, chemical data, physical parameters, information on seabed habitats, human activities, and also data on bathymetry. All of these provide a separate data portal, providing access to these resources. But on top of that, we have developed a central portal, which is a single access point where users can search the different data resources available and retrieve the most important data layers, and also providing data services to query the data, visualize it, and manipulate it. It's important also to recognize that EMODnet is more than just about access to data and products. It's about reducing the fragmentation in the landscape. It's also a platform for collaboration because it brings together almost all of the important actors that are dealing with marine data, from acquisition to access. It helped very much to raise the visibility of the wealth of observations and data that we have in Europe. And that's important because now we have many more users, many different kinds of users than was the case before. And we are also attracting more and more providers who were invisible before. So people who are organizations that hold data that we were not aware of that are now contributing to this system, which gives us better products and better services. It also helped to change the culture to a more open data sharing philosophy, and that's very important. Not only in terms of the scientific community, but also for the private sectors and businesses who are joining us in these efforts. It is multidisciplinary and increasingly global, and I think that's very important in this context. It's also a long-term effort, which is supported by DG Mare, in contrast to many of the project initiatives that are usually involved in a lot of these data acquisition and data management efforts. Why is this all important? Well, there are important benefits for data users. That's why we are doing it. It helps to reduce the costs for offshore activities. There is no need for people to measure again or survey again where data is already existing. It also reduces the costs for users to assemble data from different sources because this has already been done through the network. It also helps to stimulate innovation and competition because a wider number of organizations that were not involved before can now access data and develop applications, new innovative applications, data products and services that we were not able to think of before. That was not possible. It also helps to reduce the uncertainty in the knowledge of the behavior of the seas. That's important in terms of safety, of course, and it also helps us to develop better policies and better manage the marine environment and protect it. At the same time, there are many benefits for data providers because it increases the number of users. It helps to justify investment. You have the more data providers contribute to the system, the better and more reliable your data products are. How does it work? This is quite a complicated picture, but it is also complicated. Data generally is stored, managed in a variety of data repositories, often at the member state level, sometimes at the regional level or thematic data systems. Data flows to thematic and regional assembly groups. You have the hydrographic organizations, you have Sea DataNet and Sea Data Cloud, you have the regional sea conventions in Europe, you have the Eurogoose regional oceanographic activities, you have Copernicus Marine Environmental Monitoring Services. So there's a whole range of these assembly groups that then provide data to or make it available via EMODnet, which can be seen as a sort of shopping window where that data can be immediately accessed by the user, or he can access it through service providers or a central system. All of that is, of course, surrounded by a governance mechanism to make sure that all of these elements are developed in coherence and in an efficient way, and we play a role in that, of course, as well. Without going too much into detail, this is just to give you a flavor of some of the kinds of data that is available through EMODnet for the different teams. This is not complete, this list, and it's also a list that is continuously growing. In this phase, for example, we will be assembling and making available data on marine litter and microplastics. That will be new. We'll also make available data on underwater noise. And the Human Activities Consortium or organizations are trying to obtain vessel traffic information to develop vessel traffic density maps. And that is in high demand by our user community. Again, not to go too much into detail, just a flavor of some of the products that are being made available by the different groups. On the top left, you see the EMOTnet bathymetry, the digital terrain model, which is probably the most well-known and most used successful product of EMOTnet. But you also have collaborations with Copernicus, for example, to make available products on ice coverage, which is a very, very interesting product as well. All of these can be searched through the central portal products catalog, which allows you to browse based on different topics, the different data layers that are available. You can then either download them, retrieve them immediately, or you can combine them in a map viewer. And we are also constantly expanding the functionalities to manipulate these layers. Something entirely different that we've or that the Commission has been funding since 2013 is the EMOTnet checkpoints, which are better known as the data stress tests, where we are trying to see or assess whether the data that is available meets the requirements of actual real users. So starting from practical problems or challenges, like trying to cite the ideal location for a wind farm, an assessment of whether you can make an assessment on the connectivity between different marine protected areas in a network, looking at whether an oil leak, whether you have enough information and data available to predict where the oil leak will go and what impact it will have on the environment and on the human activities. So is the data available? Is it of sufficient quality? Is the resolution high enough to actually solve these problems? And that's important because that provides information for the monitoring programs to see whether there are gaps to be filled, whether new parameters need to be collected. And that's also a very important contribution to the wider framework of the European Ocean Observing System. So who is it for? EMOTnet is targeted towards professional, well-informed experts from 4 areas: the public sector, civil society, businesses, and the research community. And in the coming 4 slides, I will, that's the final part of the presentation, I will give a few examples of how EMOTnet data has been used in the past. And the first one is how EMOTnet bathymetry has recently significantly improved the outputs of the UK Met Office storm surge forecast model. So they have developed, together with the National Oceanographic Centre in Southampton in the UK, a new storm surge forecast model, and they've been testing different bathymetries to see what gives the best results. And using the EMOTnet bathymetry has significantly reduced the errors compared to previous bathymetries, and that's what you see on the right-hand side. So in blue, you see the errors of the outputs of the forecast model compared to real measurements, and in red, using the previous bathymetry. A lot of the data layers are also used in commercial applications. This is an example from Navionics, a company that makes mobile applications for recreational boaters, using different layers from our system. In terms of marine spatial planning, EMOTnet geology seabed substrate data has been used in the Gulf of Finland to develop a regional plan for trade in the sea area. And there was a close collaboration with our experts and the marine spatial planners in that area, and it was quite successful. If we look at seabed habitats information and maps, that's having quite a lot of different possible uses. One example on the right-hand side is the development of sensitivity maps for assessing seabed integrity, which is important or can be very useful for assessing good environmental status in the framework of the Marine Strategy Framework Directive. and also in terms of joint land use and seabed habitat maps have been used for cumulative impact index calculations. To conclude, I would just like to highlight perhaps two keywords that characterize EMODnet efforts best, and that is collaboration and interoperability. Interoperability between systems, between databases, between networks, but most of all, interoperability between people. On that note, I thank you.
Thank you very much, Bart-Jan. I think there's probably already a lot of questions in your minds. However, given that we have a couple more presentations to go, and it's probably important to make sure that we get all the information that's contained in them circulated, my proposal is that we do all the questions at the end. So with that in mind, I would suggest that we move on straight away to the next presentation on Copernicus. So please go ahead and take the floor. I have Fabienne Jacques down here for the presentation, but I take it you're not Fabienne, so so please go ahead and tell us all about Copernicus as it stands.
Yeah, so good afternoon, everybody, again. So my name is Richard Gilmore. I'm not Fabienne Jacques, as was pointed out. Fabienne is over there, and today I drew the short straw for giving the presentation. We share the work on the on Copernicus and the Marine Service. Okay. So maybe just to start with, I'd like to thank the organizers for giving an opportunity for me to present the Copernicus program, which is the EU's environment monitoring program based largely on Earth observation, but not only Earth observation, also in situ data. And I thought that, well, my first assumption was that in the audience there would be some people who would maybe not necessarily be familiar with the program, so I thought it was appropriate to give let's say, a more general presentation of what the program is about, and then maybe go into a little bit more detail on the more marine-specific aspects of what Copernicus has to offer. And I thought that a good place to start to do that would be to look a little bit at the history of the whole thing. Don't worry, I'm not going to go all the way back to the 16th century with the birth of Copernicus. That would take us too long. But I would go to the end of the last century, so back to 1998, when there was an important event which took place, which is now referred to as the Baveno Manifesto, which was a gathering of European leaders in the domain of environmental monitoring. And what came out of that was a statement saying basically that the European Union should make a long-term commitment to develop Earth observation environmental monitoring services using and developing the European skills and technology available at that time. And then you can see in the slide that a few major milestones have been indicated, and I should say also at that time it wasn't called Copernicus, it was called GMES. So Copernicus is a relatively new name for this initiative. In 2005, it became one of the EU's flagship space programs. So one of them is Copernicus, and the other one is Galileo, which is the EU's space navigation program. In 2008, we came to an agreement between the European Commission and the European Space Agency on how to proceed with GMES and then Copernicus. And then in 2013, effectively, the Copernicus program formally started. And then I've added just at the end a few more specific points of relevance to the marine community. So I think it's important to say that at the end of 2015, the Marine Service actually started its operational output. In February 2016, a Sentinel satellite called Sentinel-3A, which is very important for the marine sector, was launched. And almost immediately after that, its altimetry instrument was working. And more recently, in fact, just in the next few days, if it's not already occurred, the color instrument on board, also Sentinel-3A, should become operational. So I think that the point I want to make with this slide is that the Copernicus program is a relatively young program. It's actually formally two years old, more or less, but I want to make it clear that this is based on basically 2 decades of continuous investment and research within Europe. Looking again a little bit at the historical context and to give a few financial pieces of information. So the Copernicus program itself runs from 2014 to 2020, which corresponds to the European Union's multi-annual financial framework. And over that period of 7 years, it has a budget of 4.3 billion. And prior to that, the program, GMES as it was called then, was funded essentially through the European Union's research program, the framework program. So prior to that, it had 1.3 billion of funding in the 7 years prior to that. In this slide, it basically encapsulates what the Copernicus program is made up of, so the principal components. So in the center, you can see the heart of the system, or if you like, I would prefer to call it the brain of the system, are the Copernicus services themselves. Why the brain? Because it's their job to convert the massive amounts of data coming in from the satellites and from the in situ observation networks to convert that data into information and products that can actually be used by people who need to make decisions, so politicians and policymakers. The other major component of the Copernicus program is the space component. So on the left you can see the Sentinels, which are a series of satellites, which I will speak about in more detail just shortly, which are being built specifically to support the Copernicus program. And on the right, also a part of the space component called the contributing missions, which are existing Earth observation missions conducted by either European member states or in some cases by international agencies which contribute by providing data, in some instances which is paid for by the Copernicus program. And also, as I mentioned, it's not only an Earth observation program. The Copernicus system takes on board in situ data, and we heard about that in the context of EMODNet. So all of this is going into the services, which then give us an output products and information. Now, a few words about actually who is doing all this work, because it's very clearly a very ambitious program, and it's not something that the European Commission could do on its own. The European Commission is not, as such, an operational body, so we need other organizations to help us. And this, if you like, is the Copernicus team, the European Copernicus team, which is actually operating the whole system. So on the left, you can see for the space component, which is being technically coordinated by the European Space Agency. So they are responsible for designing, building, launching, and operating many of the Sentinel satellites. And also EUMETSAT, who is responsible for operating a certain number of the Sentinel missions, in particular those with regard to the marine sector. Then we have the services themselves. So you can see that we have a certain number of partners here. Maybe it's not necessary to go through them all one by one, but as far as the Marine Service is concerned, we have a delegation agreement with what we call an entrusted entity, which is Mercator Océan, which is taking care of operating the Marine Service. And then we also have the in situ part, which is to a large extent dependent on the participant states, so largely the member states of the EU, and all of this is coordinated by the European Environment Agency. Now this is an overview of the space component, so the Sentinels. Now this is quite a complex slide, so I'll try to walk you through it so you have a little bit of time to see what is inside the slide. So essentially it's the deployment schedule for the various Sentinel satellites. So you can see on the top there's a time scale going from 2014 to 2030. So already you can see here an interesting point is that the satellites will actually deliver their data beyond the nominal duration of the program, which means if you put that into the general context, it means that we've got here basically 3 decades of continuity of Earth observation-based environmental monitoring. Then you can see that essentially there are 6 families of Sentinels. In total, there are 19 satellites which are foreseen to be launched over the period 2014 to approximately 2025 or so, which has earned the Copernicus program the name of the most ambitious Earth observation program to date, which I think you can understand when you see the rollout of satellites. You can see also where I've put the red ticks. These are satellites which have already been launched. So we've launched 5 satellites so far without any major mishaps. So they're all in orbit and functioning properly. And you can see a small thumbnail image of the launch itself. Those of you who are interested in space technology and launches can probably identify from the silhouette of the launcher which launcher we use to put the satellite up. So as I said, there are 6 families of Sentinels. So I'll just quickly go through what the specificities of each family are. So Sentinel-1 is essentially based on radar technology. Sentinel-2 is essentially based on imaging technology. Sentinel-3 has several different missions on, but those of particular interest to the marine community are the high-precision altimetry and the color instrument. Sentinel-4 is relating to atmospheric composition, as is Sentinel-5. And then Sentinel-6 is, again, a high-precision radar altimeter, which is actually the follow-on of the JASON programs. Now, I've highlighted in red those missions which are of specific significance to the marine sector, so Sentinel-3 and Sentinel-6. But I think we can say that almost all of the Sentinels have some degree of significance to marine. So, for example, Sentinel-1, with its radar capability, gives information on ice and also the presence of vessels. Sentinel-2, which was originally designed, or was designed with in mind the observation of the land, it turns out it's also quite useful for looking at the sea, but in the coastal region, and it's actually complementary to what Sentinel-3 is providing because it's a different level of resolution. So that was the space component. So again, a few words about the services component, which we already saw briefly. So there are 6 services. So there are 3 services dealing with Earth systems as such. So you can see on the top three, so atmosphere monitoring, marine monitoring, and land monitoring. And then we have three services which are, you could describe them as being cross-cutting. So in relation to security, emergency management, and climate change. So now I'm going to focus a little bit more on the marine relevant part, and in particular the marine service itself. And yeah, another important point I think to highlight here is the data policy of the Copernicus program, is that it is full, free, and open, which means that anybody can access the products or the information coming out of the information, or indeed the data coming out of the satellites. And that means not only in Europe, but worldwide. So obviously of interest to our Chinese colleagues here today. So a few words about why the marine sector is so important. I think we already heard several of these arguments from during the presentation on eModNet. So the blue economy, so 5 million jobs, an added value of 500 billion a year. 90% of international trade is maritime. Half the world's population lives close to the coast, and that's a particularly important statement when we think about the case of the European Union, which has a particularly long coastline compared to other parts of the world. Also, the question of renewable energies from the ocean is becoming quite a hot topic these days. And of course, the ocean plays a critical role in the climate system. So the effect of climate change on the ocean and the effect of the oceans on climate change. So it's the oceans and the marine sector in general is therefore a very significant area for EU policy. So I've listed just a few recent policy areas where marine is really a central issue. So a few words about the Marine Environment Monitoring Service. So it is essentially the Copernicus's forecasting service for the marine sector. So just very briefly, it is covering a certain number of parameters. So you can see here some physical parameters, things like ice, current, temperature, sea level salinity, but also biogeochemical aspects which are derived, for example, from measuring ocean color, the possibility to follow the concentration of chlorophyll, the presence of plankton, and these kinds of things. In terms of geographical coverage, the service is global, but it also has obviously a European focus. There is a focus on 6 European regional seas for which the resolution is higher than for the global observation. So we cover the Arctic, the Baltic, Northwest Shelf, the Iberian Sea, Med Sea, and the Black Sea. So again, just to reiterate, I already mentioned the parameters that are covered. So you can see the physical parameters, and also I highlight again the biogeochemical parameters, so transparency, turbidity, reflectance, oxygen, primary production, plankton, and nutrients. So here just a few key milestones on where we stand with the Copernicus Marine Service as of today. So as I already mentioned, the service became fully operational at the end of 2015. It builds on quite a significant research heritage prior to the Copernicus program, building on research projects such as MERSI and MyOcean. The Copernicus entrusted entity, as I already said, which is running the service, is called Mercator Océan, which is based in Toulouse. The service itself is currently running version 3, which provides 152 individual products. And a new release of this is foreseen, well actually it has come out at the end of April, which now includes waves, and a version 4 is in preparation, which will bring, for example, improvements to a number of biogeochemical parameters and the inclusion of ocean monitoring indicators. The service has now close to 10,000 registered users, if it's not already gone beyond that. The users are mainly from the European Union, but as I said, as a result of the open data policy, there are a lot of users outside Europe. So from America, 16%, and from Asia, 16%. So I'm sure quite a significant percentage for Asia is represented by China. Another important milestone this year is the publication of the first ocean state report. Now I come essentially to the end of the presentation, but I thought it would be nice to end with a few concrete examples of what the Marine Service is actually providing. So here you can see an overall list of some of the areas where users are making use of the Marine Service. So ship routing, offshore activities, coastal management, oil drift forecasting, sea ice forecasting, search and rescue, fisheries and algal bloom issues, water quality management. And of course it's important to highlight again that climate change also benefits quite significantly from the information we can gain on the oceans. So here one specific example of so-called current routing. So this is an example provided by an actual shipping company that was able to reduce their fuel consumption by 0.40%, and they hope to be able to build on that to get a 1% reduction of their fuel consumption simply by optimizing their route to make best use of the currents, which are forecast by the Marine Service. In the case of renewable energy, so one example here is that of oceanothermal energy conversion. So obviously it's extremely useful to be able to have a very clear map of the sea surface temperature to know where the best place is to position the production plants. Another example here, that of search and rescue. So an agency which has actually done a test of the drift forecasting, and as you can see here, the user was very satisfied by what came out. Here, the issue relating to Fukushima. So the Copernicus Marine Service was involved in helping out with current forecasting so that the Japanese could develop their risk mitigation plans based on the dispersion of pollutants. And then we heard earlier today about, in the introduction speeches, about the importance of litter. This doesn't give any information about where the litter is coming from, but it does help us to understand where it ends up. And this is something from the so-called Seventh Continent expedition to try and find out where all this debris ends up in the North Atlantic. And here just another example of how the color instrument on Sentinel-3 can be used to map algal blooms, for example. And then just one final image, and this is an image from the color instrument on Sentinel-3A, just to show how we can follow the chlorophyll A concentration around the globe. And that brings me to the conclusion, so thank you very much for your attention.
Thank you very much. I found that extremely interesting, particularly the last bit I found very captivating. And before we go into the next presentation, just one remark, because one of the things we're trying to do is to see what can we use these data for, and in particular, how can we make them most useful in a context where environment meets business or business meets environment, for example, or economic activity meets environment. And what occurred to me is that if you can do something about route forecasting, reducing fuel expenditure, and ultimately also reducing CO2 emissions, is that actually part of the discussions in the MEPC, in the IMO, or is that only focused on how you change engine performance and fuels and so forth? So that's something that's worth following up. Obviously not necessarily today, but something that I think would be worth picking up at some later stage. Okay, I don't want to take any more time because we do have to move on. So Venezia, I think you're up for the presentation now on the data collection framework. You have the floor.
Thank you very much. I'm going to talk to you and present to you the so-called data collection framework that has to do with the collection of fisheries data. So just to take you through the presentation, I'm going to talk generally about the context of this framework. Then I'm going to describe what data is collected, how it is collected, what are the procedures that we use, and what are the challenges for the future. So, for the context, the data collection framework is a framework to collect fisheries data. It is essential to provide scientific data for the implementation of the common fisheries policy in order to be able to take informed decisions for the conservation and sustainable exploitation of fisheries resources. The data collection framework is composed of a number of regulations and Commission decisions. The regulation has recently been revised and has been adopted, so it will soon be published. And the reason for this revision was to reflect the latest common fisheries policy regulation, and where we have new data requirements. And we also made an effort to simplify procedures and make data more available to end users. In addition, we have a number of Commission decisions. The EU Multi-Annual Union Programme, where in that document the data requirements are described for Member States to collect data on fisheries. And we have the work plan template, where Member States have to produce a report on their planning of data collection activities based on the data requirements of the EU multi-annual programme, but also on how they will collect the data, on the quality of the data. So why do we collect data? The data for scientific purposes is collected through the data collection framework. And this framework creates a legal obligation for Member States to collect data. This data is stored in the national databases. So this data is not stored in the Commission or in DG Mare, but the data collection framework creates the obligation for Member States to collect sets of data. And then the Member States collect this data and make them available to end users for scientific advice, like ICES and STCF. So data collected by the Member State is requested by end users, and these end users provide scientific advice for the Commission. And based on this scientific advice, the Commission produces policy decisions that are addressed ultimately to the Member States. And this whole circle is to serve the implementation of the common fisheries policy. So the data collection framework establishes rules for the collection, the management and the storage of data on the biology, environment and socioeconomic data for fisheries, aquaculture and the processing sector. And also establishes rules on how this data is used by a number of end users. So what data is collected? For fisheries, We have the so-called fisheries-dependent data. That means that we collect data on the commercial vessels fishing. So we have biological data for a set list of stocks per area, where we measure the length and the number of biological parameters. That goes for EU waters and outside EU waters, wherever EU fishing fleet is fishing. We also collect data on recreational fish stocks and also on eels and salmon. Then we collect data on the fishing activity, meaning the capacity, the fishing effort, the landings, and this data comes from another EU regulation, which is called control regulation. But the data collection framework also foresees the alternative data collection for fishing fleet segments that are not covered under this control regulation. So for all commercial catches in all areas, we collect data, member states collect data on the fishing activity. A new element on data collection is the impact of fisheries on the marine ecosystems. There, we're asking member states to collect data through pilot studies because this is a new requirement. So they are asked to collect data on the incidental bycatch of commercial fisheries, impact on the marine habitats, and on marine resources and ecosystems. These requirements are quite general because we want member states to explore how to collect data and which data would make more sense. So it's a new area to be explored under the DCF. And then on the socioeconomic side, we collect a number of socioeconomic parameters of the fishing fleet. Again, on fisheries, we have another category, which is called fisheries independent data. And there we have scientific surveys, which means scientific vessels that go at sea and collect a number of biological parameters on fish stocks. And this data is also used to compare to the fisheries-dependent data collected in commercial fishing vessels. For aquaculture, we have a number of socioeconomic variables. And also a new element is the environmental performance of aquaculture, where data will be collected on medicines and on mortalities. Marine aquaculture is compulsory, but freshwater aquaculture is voluntary. And for the processing industry, this is also done on a voluntary basis. We have a number of socioeconomic variables, but most member states, although it is on a voluntary basis, they still commit to collect data for this sector because they consider it very important. So how is data collected? Member states, as I said, have to collect data on the commercial fisheries and aquaculture and the processing industry. So they collect this raw data that is called primary data. And this data is stored in national databases in the national research institutes of each member state. Then this data is processed and aggregated, and end users of this data request it either in the form of a punctual data call or as a recurrent reporting obligation. So end users request specific data from the member states, and then this data is used in the mechanism to produce scientific advice for fisheries management, for policy development, and there's also requests for scientific research. All these requests are the way and the deadlines and the timetables to ask and launch these requests are described in the regulation, and there are specific time frames to do so. In addition, there is fishing activity data, as I mentioned, that is collected also under other regulations, which is the control regulation, but still used in the data collection framework. And there's also data used collected under Eurostat, but it's also partly used also under the data collection framework. So there are a number of regulations where data is collected, but there has been effort to streamline those regulations so there is no overlapping and duplication of data being asked from different regulations many times. So member states have different ways to collect this data. They have scientific observers that go on board of commercial vessels, and there they sample part of the catch. So they're doing all the measurements they can on board, and then they also take samples to back to the laboratory to do further work. We have the scientific surveys, but we also have harbor sampling of landing. So we have observers that go at the ports where the landings take place, and they sample also that process. And of course, for the socioeconomic data, we have questionnaires and surveys to collect the requested data. What are the procedures? We have this EU multi-annual program where we have all the data requirements. And this has been a procedure where we have consulted different scientific bodies. We have consulted scientific institutes, the member states, different services in the Commission to try and define what should be the data requirements for fisheries, aquaculture, and the processing industry. And based on this consultation, we have produced this multi-annual program where we have a set list of data requirements. These are implemented through national work plans, so member states, based on those data requirements, they have to describe their sampling activities for the future through these work plans. And based on this reporting, they collect the data and they have the legal obligation to transmit it to the end users. They also have reporting obligation to the Commission, where they have to report how they have implemented the data collection activities. And there's monitoring of this DCF implementation by the Commission. So it is a process that has a lot of set procedures, and we try to be very close to the member states and monitor how the data collection is being implemented, and we are working hand in hand with member states. In addition, there is member state coordination at regional level, and this is becoming very important in the new regulation. So we have a number of the so-called regional coordination meetings where we have experts from member states and the Commission meeting once a year and discussing data collection on a regional scale. So we have one RCM on the Baltic, one on the North Sea, North Atlantic, Mediterranean and Black Sea, and long distance. This categorization has to do with the different marine regions that have different needs. So in those meetings, the data collection is further discussed and adjusted based on the areas. And we also have a planning group for economic. This is at an EU level where we discuss the socioeconomic data collection. So the challenges for the future is this regionalization. In the new regulation, we foresee a transition from the regional coordination meetings to the regional coordination groups, where they have to take a lot of decisions on data collection. They can add more data requirements based on the region, and they will have a very central role in data collection. And another challenge is the data availability, as has been said in the previous presentations. We are trying to work on compatibility, so we have a lot of different databases in data collection at national level, at regional level, at EU level, and we're trying to work on compatibility and also how to disseminate data. And it's very important to try and link to all those different initiatives. And it's true that there's a lot of data that is available at different places, but we need to be aware where data is available and try to link it and see what we can make the best of it. So in a few words, the data collection aims to harmonize and strengthen fisheries data collection at an EU level, to make data available to the scientific community, and we have a strong regional approach. The data is collected on a fleet base, and in order to serve the common fisheries policy, we're supporting the ecosystem approach and also database development. Thank you very much.
Okay, thank you very much. We have 8 minutes left before we are supposed to be breaking for coffee. I can also see a little bit of a reduction of the energy levels in the room. We've been going at it for about an hour and a half now already. So we have two options. Either we start with the questions and answers now and take the coffee break a bit later, or we take the coffee break now, but end it at, 4:45, because we're not a very big group, and do the Q&A after the coffee break when everybody's revitalized, and we then move into the second session. I see some sympathies for that option, so I think that that's then decided. So let's break for coffee now, and then we come back here at 4:45. Okay?
Hello, everybody. Can you hear me? We continue to this afternoon the meeting, second session. Before the second session, three presentation, we spent a couple of minutes for the question. We had a very good three presentation from your side. It's a lot of information. Maybe our China delegation, our colleague, have some question or comments. Any question or comments? Please.
In fact, I have three questions for each presentation. My first one is for Jen. And thanks for the introduction for the EMONET. And I think right now I have more comprehensive understanding for the project. In your presentation, you have mentioned a plan to 2020. You are going to reach a seamless observation, a kind of seamless observation. I would like to know what's the current status of the observation. I mean, such as the spatial resolution, for that was the current resolution for that, and also what's your final goal for that, for the spatial resolution, how you define those. This is the first question for Jen. Or I continue for my next question?
Yes.
Okay. My next question is for Fabini. Yeah. Sorry if I may not pronounce the name. Yeah. In this presentation, I noticed is for the climate change. It's not in operational. It's just in ramp up. I would like to know what variable has been observed for the climate change, and when would you expect for it will be operated? This is the second question. The third question is for Winter. Yeah. Thanks for introducing this. I think it's really hard to collect all those data. I'm just curious how those data are used. Do you have any user for the fishery data? Yeah, that's it. Thank you.
Thank you. So currently we are working with the EMONET bathymetry about 1/8 arc-second, and we're working towards a resolution of going towards 80 meters in the future. And the idea of the seamless multi-resolution mapping is that where possible we'll provide that resolution, where in areas we don't have that resolution, we will provide higher resolution, a lower resolution, but it would be easier for a user to zoom in where it is available. So we don't go for the lowest common denominator, but we will go the highest where it is available.
And also in some specific region, maybe you need much more resolution.
Yeah, it will be. There will be areas with a higher resolution.
Mm-hmm. Yes, no, absolutely. Where possible, we can go high resolution, especially in coastal areas. We'll try to provide more high resolution data. In fact, our latest EMONET bathymetry is called high resolution seabed mapping, and is focusing a lot also on the coastal area where the surveying is much more intense.
So maybe I will answer to the second questions on the climate. So on the climate, there is two separate things. you have seen that in the Copernicus services, you have 6 services. One is the Marine Service, another one is the Climate Service. This Climate Service is producing the essential climate variables that are defined by GCOS, including the ocean one, like sea level, SST, and so on and so on. Therefore, so this service has started 2 years ago. They are in the ramp-up phase, but they become operational. So the data are available, the ECVs are available now. What is in ramp-up? This is the interactions between the Marine Service and the Climate Service.
Okay.
So the Marine Service is supposed to deliver the 40 years reanalysis. That will be used by the Climate Service to produce the ECVs. And this is this work between the two services which is ongoing at the time being only.
Okay. Okay.
But it will be done soon, I think at the end of the year.
Okay.
Something like that.
Yeah, thank you.
Regarding your question on the end users, the DCF is meant, the purpose is to collect data to be used and for the purposes of the common fisheries policy. And in that framework, we have specific end users that regularly ask for data, and these are scientific bodies that cooperate with the Commission, like ICES and the STCF, where they ask data collected under the DCF, and they use these data to provide scientific advice for the Commission. We also have other users, like the regional coordination meetings so these groups that work on a regional basis, they ask for data from the member states fishing in that region, and based on the data collection, they take decisions on how to change or amend their data collection in that region. We also have scientific institutes asking for data in different initiatives. So it's quite, member states are quite busy sending the data collected under the data collection framework to different types of end users.
If you have done some research on the fishery model, I don't know if someone do that. If someone do that, I mean, for the fishery forecasting, maybe in future, they will use those data as well. Just a comment. Thank you. Okay, I'm fine. Thank you.
It is very clear that regarding maritime data, in the past, it was very difficult because the data is very precious to collect. It is important that different countries collaborate on data. So about the global booth, and we have our different goose system. Every country is also joining different international programs, and then it is possible that they can share this data under different frameworks. I would like to know, under EMODnet, when you have collected different data or data from different international cooperation, there are actually some repetition of data. We know that wrong data can lead to a wrong interpretation or wrong result. I would like to know, when you have a repetition of data, it may also lead to a wrong conclusion. How do you deal with the repetition of data if there are some repetition or duplicate of data?
Yes. This repetition, duplication is an issue. I know we've done some tests, for instance, looking at nutrients in. I mean, Jiangxi has actually, from the Danish Meteorological Institute, has actually done some analysis comparing different sources of data on nutrients in the Baltic Sea, and there were some differences. I mean, I think the answer must be in labeling correctly the data so that you can identify the duplications, so that you have the date, the time, and try to find unique identifiers. And I think, and I believe that some of our teams are working on this type of issue, yeah.
Thank you. Any other question?
Yeah.
Sorry, we cannot hear.
Is called a sea basin checkpoint that's in different sea areas to assess if the data are sufficient, if they fit for the purpose of use. In different areas, they have this sea basin checkpoint data adequacy report that you can get from the website. Yeah, the last question about fishery model, Rasmus, tomorrow he will give some detailed presentation on that.
Do you use something? Yeah, tomorrow maybe introduce that.
Yeah.
Thanks, Dr. Sher. Okay, if no any other question, we started the following three presentations from China delegation. These three presentations focus on the marine forecast and ocean data management and information management. The first speaker is given by myself. Yeah, I need to move to it. Okay. The topic is operational ocean observation and forecasting service in China. Okay, it's my pleasure to have this chance to introduce China some activity for the ocean observation, both including the operation and general scientific observation, but the most focus on the some of the slides included the operational observation. Another part is the forecasting service. I come from the National Marine Forecasting Center. This center was established in 15 years ago. It's mainly focused on the marine forecast service. You know, in China, the parallel, the CMA then provides the weather forecast, covers the Chinese mainland and the the whole other the region. For the CMA, not including the marine forecaster, the SOA, we provide the marine forecaster service for long history. How it doesn't work? Huh?
Maybe press this.
My presentation is three parts. The first part is the marine observing system in China. The second part is the marine environment forecasting and disaster warning service. The third gives some of the suggestions with the China-EU collaboration and also introduce some of the current situation, especially our center with European countries, some of the partner center. For the goods, it covers the global ocean. The sub-region like near goes is a member from the China, South Korea, and Russia and Japan. We run roughly over 20 years near goals. In our center, we provide the real-time data to this the regional goals to the member state. Also, we provide some of the marine forecast products. Those real-time data is come from the some of the station from Chinese coast region. Is Operation Ocean Observation Station. For the forecast service, we provide some of the Northwest Pacific wave and sea surface current, and also including three-dimension current and temperature and salinity, also including sea ice. Yeah. Every year we meet together with this region. We talk about to build the platform and to provide the data sharing. This member, the country, it's I think it's we made a contribution to the global goals, the program. This is a distribution the station coming from the Chinese coast into the this platform real-time the data. Also including the buoy and some of the VOS the data. We use the GTS method, use the GTS network, transfer the data, both for the atmosphere and ocean, the data. Also use the GTS and to transfer the marine forecast products. In China, where another contribution to the global ocean observation is we provide some over 300 Argo float. At the moment, we have over 100 Argo float. It still work in the open ocean. This data is available for the Argo network. At the same time, we get the satellite data, remote sensing data, both from China satellite center and also from overseas countries. Like we get the satellite data from CRS that covers the regions Indian Ocean and the Northwest Pacific Ocean. It's very useful for the marine forecast, like forecast, wave forecast and current forecast. By the way, I want to mention AMEFC, we get the permission from IOC. We run the regional tsunami center, is South China Sea tsunami center. You know, the Pacific Ocean is a PTWC based in Hawaii, then provides the whole Pacific Ocean's warning, tsunami warning service. For South China Sea Tsunami Center, through the couple of years the build, we have a plan. At the end of this year, we will provide the formal service to the South China Sea surrounding country. This month in Paris, IOC assembly, the meeting will approve our center, this center to provide the service to the surrounding the country. Is through a couple of years the building is we get the some of the during this period we get the over 500 global seismic network data in real time. Yeah. We have the ability to judge the seafloor earthquake. After get the earthquake information, we start our tsunami wave, the forecast system to judge the tsunami, the impact to the Chinese coast. This slide shows the Chinese coast operational observation network. Our administrator Wang Hong mentioned in his speaker in China coast through 14 years construction, we build, at the moment, we build the very comprehensive operational network, operational observation system for the ocean side. Like at the coast station, we measure the time, we get the tide data, use the tide gauge. Yeah. In the coast region, we also run the buoy system, some of the ground wave radar, and other measurement, operational measurement. Also, we get some of the real-time data from other agencies, like Chinese Academy for Science. They have some rounds, the yearly rounds of some of the stations in the Chinese coast and other regions. We use some of the VSAT and other the method to transfer the real time the data into the operational forecast system. Yeah. This slide shows you some of the station based in Chinese coast area. So many the measurement is automatically, like we measurement sea temperature and salinity and regular meteorological and other ocean data. This data transfer from the local station to the national center. This shows some of the radar. It can get the real time the sea surface temperature. Also, like in the north, the Bohai Sea, we measure the ice coverage. This is the buoy system. We have two tsunami buoys in South China Sea. Other the buoy system is run separated by East China Sea branch and North Sea the branch SOA, and together the operational observation. We also use the ship to get the infield the data. For the polar region, we use Xuelong. Many others middle scale and middle size ship along the Chinese marginal sea to get the observation data. Also, you use the commercial ship to get the VOS data. This is the CMS airplane used for sea ice, red tide, oil spill monitoring, and emergency surveillance. In Chinese SOA, we also have a center to focus on the satellite. At the moment, HY2 is to do some of the ocean dynamics measurement. Some of the data is into our forecast system. Other Chinese organizations like Chinese Academy of Science, Institute of Oceanology, or Ocean University of China, Ministry of Education, China, the couple of years, then get the support from the Chinese funding agency to run some of the open ocean observations work, like the Korochu area and India Ocean. Also included some of the institute from SOA, like First Institute of SOA, then put one or two the buoy in the Indian Ocean. The second part is marine environment forecast situation. At the moment, we have roughly three levels. The one level is nation level, is all center, AMEFC. Below this level, we have three regional forecast center. Their responsibility is to focus on the regional forecast Now below this level is local government. Is we call it the city level or president level. The local is provided the service to the for the local government, the local public. We provide the like the ocean wave, storm surge, tsunami, sea ice, temperature and current. Also use the current forecast result. We build the forecast system for search and rescue, and also including the oil spill and other emergency response demand. In the past 10 years, the most development for our center is the two aspects. One aspect, we build a very high resolution in the coast region, like every typhoon season, Chinese coast area, we meet a lot of problem with the storm surge. Like in Chinese coast area, many of the local government build the dam along the Chinese coast. We build a very high resolution to judge one process over the dam and to very high resolution service to the local government. It's very useful for the typhoon season. Yeah, this is some of the data simulation use the satellite. For the tsunami warning in the coast area, we also build some of the very high resolution tsunami model. The other part is development is we build the global coverage marine forecast system. You know, in the European country, Mercator Ocean then build the cover the global ocean forecast system can provide the three-dimension current and temperature and salinity. Use the NEMO model. For the United States, like NSAP, they use the HICOM and other type the model to build the global marine forecast system. For our center, we build the Chinese global operational ocean forecast system, SEAGOP's version 1.0, including the 7 different regions, the global region, the level 1, and Northwest Pacific Ocean, Indian Ocean, yeah. Also including the polar region. We can provide the global coverage, the basic marine forecast products. Like surface wind and temperature and polar ice, wave and tide current. Yeah. This version 1 is a little bit across. It's not so high resolution, but we have a plan. Maybe end of this year, we use 112 the high resolution global forecast into the operational. Yeah. This high resolution global forecast We also based the NEMO, the model, is used by the European, like Copernicus, the program. Yeah. We have some of the exchange with Mercator Ocean, and we the two systems intercompassing and some of the work. Yeah. Because time is very limited, I cannot introduce in the detail. But in the near future, in China, we get under the support of some of the national program. We can get 2 or 3 the system for the global coverage system. Yeah, we can make the multimodal forecast system. The other development is Arctic and Antarctic sea ice, the forecast. It's very useful for like Arctic Ocean for the commercial ship for the summer season across the Arctic Ocean from China to the European country. We have some of the service, like from 2013, for the service for Yongsheng, yeah, the Chinese commercial ship, and last year we provided service 5 commercial ships across Arctic, so it's very very good performance this system to the to support the ship routing service. Yeah, by the way, we also provide some INSO prediction. Yeah, we use different China Institute Center. We use different model to build the multimodal to get the better prediction result. This slide shows how to provide our products to the public. We use many ways, TV program, broadcast, website, and short message like use a cell phone, and many the way we provide our products to the public is the information is very easy to get for the public. We're also for the national center, we discuss with the forecast center with regional forecast center, yeah, to get the best forecast result. In the near future, for the service model, for the marine forecast, it's from the single factor forecast into the target oriented comprehensive forecast support. Like the very successful forecast service example, like China government spent 7 years used to build the big bridge, including the submarine the system from the Hong Kong to Macau to Zhuhai. Yeah, we provide this service. Is a combination the sea wind, sea current, and suspended sand and other is a very service to the very high resolution to the target. This is for the bigger ocean engineering service. This is very successful nearly finished this work. The other way aspect is from nearshore to the global ocean. That's I mentioned for the global forecast system. The third field is from physics oceanography, physics forecast to marine biology, ecosystem forecast. You know, international the program Godet Ocean View. This international program, the office based in the Meta office. I'm a member of the advanced committee. This program is supposed to not only the global coverage of the physics, now as they try to build the marine ecosystem forecast system. The following slide introduces some of the activity in past several years. We have some of the link with European countries like China, Italy, cooperation with Operation Oceanography, with AMEFC, with CMCC, also other organizations like OGS. We regularly organize the joint committee. About one month ago, we have a joint workshop, a very successful workshop in Roma with Professor Pinati and Nadia. We have a lot of discussion with open ocean for marine forecasting and coast forecast. China FMI Finland cooperation is mainly focused on the sea ice and weather forecast. We also assign MOU. In this month, we will send a delegation to Finland FMI to sign, renew the MOU and organize a joint workshop. With Germany, we also with RV, Blame RV. We focus on the polar prediction project. Last year, we hosted WMO PPP annual meeting. We signed the MOU with Blame RV. Focus on the polar prediction. This year, from 2013, 2019, is polar prediction years. This year, SOA will send the Xuelong to Arctic Ocean to make a link with the international program. The China-Norway cooperation also focus on the sea ice and ocean carpeting model and some of the joint observation. We will sign MOU in November this year. With the Mercator Ocean, we work together with some of the academic technical exchange for the marine forecast. Mainly focus on the global ocean forecast system. In this month, we will host a joint workshop in Hangzhou, in China. Finally, I want to take 2 or 3 minutes to mention. I think we can work together. We can to build some of the co-interesting area like one road some of the like the port forecast system from South China Sea to the Indian Ocean into the Mediterranean Sea. It's, I think it's a lot of potential co-interesting. I suggest we can under the EU-China blue years, and under this framework, we can build some to do some of the joint work with like one road. It's a lot of demand for such a region for the marine forecast. And the European country here is the global marine forecast is, I think, can provide some of the very good the products for this region. Also, China, some of the system we can make some of the link. Yeah. Okay, I quickly finish all my presentation. In the near future, some of the streets like the Indian Ocean, other streets, and other the port, different regions, the port the system, we can build a very useful, can meet the demand, the local user and the international user. It can enlarge the marine forecast, the impact. Yeah. Finally, the future research and cooperation priority, I think, is like a joint development marine forecast network and operational ocean capability. Development of global and coastal ocean forecast system, intercapacity and validation, observation the system, climate change and prediction. Second one is to provide a service for the country along the 21st century's maritime scenic route. This is my suggestion. Thank you very much. Okay. Yeah, I change the. We continue this second speaker. After three speaker presentation, we following the discussion and comments. The second presentation, also from MEFC, Dr. Liu Guimei. Topic is development and application of regional operational forecast system in China Sea. Please. Okay.
Follow Professor Wang's presentation. I'm going to touch the detail of what we have done for the China Sea's operational forecasting system, what we have. I'm going to follow the 5 points. First, this is the 3 systems what we have for the regional forecasting system. The first one is the Northwest Pacific region. In this region, we will cover the whole regions along the China coastal region. And also this big region will provide ocean boundary condition for the second region and the third region. And in fact, we also have a small region for the Bohai Sea. The second region is for the East China Sea, and the third one is for the South China Sea. And the first region is the Northwest Pacific region. In this region, we have the resolution is 120, and the vertical level is 30 levels. And also the boundary condition, we use our global operational forecasting system to provide the ocean boundary condition for our system. In fact, we have done a lot of model validation due to the time limitation. I only maybe pick some special points to show that. This is one of the points outside the Yangtze River. This region is a crucial region. So you can see this one, upper panel is our model result, and the lower panel is observation result. For U and V, they at least we think the model results and the observation, they shows agreement very well. And another one is for the sea level comparison with abyssal data. In fact, yeah, so we have 20 years of comparison with that, comparison between them. So this shows also agreement for that. Here shows the product, what we have for the temperature, salinity, and the current. They are also provided on the website of our center. Another coastal system is East China Sea. So in this domain, the resolution is about 130, and also vertical 30 vertical layers as well. And also, in fact, in this region, we also consider 10 tidal constituents, because in China, the tidal effect is strong along the China coastal region. And also, we covered the Yangtze River, the river discharge, because it has a large river discharge into the system. Since we have cooperation with Korea, so we have some observation from this profile. This is an FRDI observation, and we have compared our model with the observation. They look fine, in fact. And another one, we also compare the U and V, the water current, with our observation. So the also upper panel shows observation results, and the lower panel shows model results. This shows an agreement. So I think, and also for sure, a lot of other validation which I didn't show here. So I think the system is robust to forecast for the temperature, salinity, and the current. Here's the products we have in our website for the temperature, salinity, and the current. Another system is the South China Sea. The horizontal is for the 30 layer, 130 as well, but this one for the vertical resolution is 36. And also the boundary condition is provided by the Northwest Pacific Region Operational Forecasting System. We compared with the observations. In fact, due to we have cooperation with Mercator, with France, so we have compared our system with Mercator system. So you can see here the left panel sorry, the left panel. The upper panel shows temperature, and the lower panel is salinity. The left two is for the observation, and the middle one is Mercator result, and the third row is for our center's result. So you can see, at least we think for the Mercator and our system can resolve some main feature for the observation, but not can capture the much detail for that. We know the numerical models has a problem. Yeah, they can't deal rarely got the most true result as the real world. And also here is another point. You see this is a station for the observation we have for the Maoming. We have buoy data there, and you see from the comparison for the Mercator, this tool shows Mercator result for U and V, and the lower two shows is our center's result. For the root mean square, for the Mercator result has better results than our center, especially for this event, for the typhoon event. Mercator got a much better result than our center. However, in another station, at Nansha station, so in this station, we can see for our system, we have better root mean square error than the Mercator system. So we think for both systems, they can behave well, and also the performance is good for both systems. At some region, maybe Mercator system has better result, but some other region, the Chinese operational system has better result. Here is the products, what we have for the South China Sea: temperature, salinity, and current. And also along the China coastal region, we have high-resolution model. Here, this one is just one of the Daya Bay. I just give an example for that. In fact, we have several systems for that. The resolution is less than 200 meters. We use FVCOM and unstructured the grid of the model. We have do the model validation to compare with the tide, and also to compare with the real observation data. We have done the observation, and in the real coastal region, so we can see for the current, water current, and also current direction. It's hard for us to resolve the observation much better, although we have high resolution for that. So we think for the coastal region, the observation is much important for our model result. And here shows some forecasting validation. And next, I will introduce a little bit data assimilation scheme, what we used in the regional model. For the Northwest Pacific system, we use in that model optimal interpolation, both on sea level anomalous and also SST. And also in Northwest Pacific region, we use 3D VAR on SST and Argo. In East China Sea and also South China Sea, we only use in that mode OI on sea level anomalous and SST. Here we use in that mode OI system in the East China Sea. So we can see the black line shows the free run, and the red line is after we use in that mode OI, it can increase a lot to improve our system forecasting result. Here is a ENOI scheme we used. Sorry for that. We used for the ultimate sea level anomalous. In fact, for this is observation. This is before a simulated result, before simulation model result, and this is after we simulated the result into the system. We can see, especially some ID region, it improve a lot. And another one, we use 3D VAR scheme on the Northwest Pacific region to simulate the SST result. This is the, after 5 days, the root mean square for the Northwest Pacific region for the SST is under 1 centigrade. And also this is we use 3D VAR to simulate the Argo data into our system. So you can see for this, for the black line is assimilated, but the red line is assimilated. This as well. So after assimilated Argo data into the system, the accuracy for the system can improve about 28%. For those applications, it has been used several aspects. Just Dr. Wang has introduced for the global system. I will try to talk about some use in the regional SIS. We have used several part of that. First, we have, based on the physical result, we have established the marine ecosystem forecasting system. This is an ecosystem we used. It's driven by the ROMS model, and we have the nitrate, phosphate, phytoplankton, small zooplankton, mesozooplankton, ammonia, and deltas, and also we coupled with carbon system. This is the initial condition for all the biological, biochemical data we used, and also the nutrient loading and all some parameter setting. And we have compared our model result with observation. Here shows the chlorophyll at SIS. In fact, the SIS is located in the South China Sea. Our system can resolve very well for the subsurface maximum of chlorophyll concentration for both stage, for both time. Yeah, one is January and another is in July. This is another comparison with based on comparison with nitrate. So but it's compared with WOA. For the spatial comparison is based compared with WOA 09. Based on our model result, we try to do some research studies. We noticed that for the PCO2, it's increasing. It's keep on increasing in the China Sea region, and also the increasing rate is it's about 1.11 mu ATM per year. And also, in fact, the pH is in decreasing trend. Decreasing trend. The rate is about 0.001 per year. So it shows the ocean is in acidification period. And we try to do let the system do the operational test. We try, here is a system frame. And what here introduce about the forecasting flow chart. Currently, we have the chlorophyll, dissolved oxygen, ammonia, nitrate for variables. It's in operational test right now. Another application is for the search and rescue. We have used, based on those circulation results, we have provided a lot of search and rescue case. One is, I don't know if you remember, for the Xisha butterfly typhoon. This is one of case we have worked on. Another one is for the MH370. One is we try to trace back where the suspected species is come from. We based on different variables and try to trace back that. Another service we provide for one of the debris where it's going to be in the next 3 days based on the different parameters as well. So the region will be different. And also we provide the service to try to trace back, such as we found some debris, suspected debris here, and we try to trace back where it's going to come from to support the government decision. And another application is for the oil spill. So in our center, we also do the oil spill forecasting as well. And the full application is for the marine hazardous materials transport. I think in Europe you you also introduced for the Fukushima contaminants, you also has done the similar result as well, but I didn't show it in this presentation. This is for the Tianjin port contamination forecast, what we have done in that time. And also we have done, based on those results, we do the environmental forecast, such as Jiaolong provides the forecast for the Jiaolong exploration, and also for the city along the coastal region. Well, that's the summary. Right now, we have the not those systems. Yeah, those systems, Northwest Pacific, East China Sea, and the South China Sea system has been used operational and every day, and we are trying to develop some ecosystem model in operational. I know in European side you have done really a good job in ecosystem model. That's why I later on introduce more on the ecosystem model, what we are trying to do. So I'm thinking maybe in this aspect we can do more cooperation on that. For sure, we also have oil exploration and also search and rescue research as well. And in the future, we try to extend our forecast range, develop the forecasting system, and also constructing the observation as well. So we would like to use more observation data into our system to improve our forecasting result. Okay, thank you. That's it.
The last presentation given by Professor Xiang Wenxi. His topic is state and the future of marine big data in China. Yes, please.
I'm very happy to give you a brief introduction on the status and the trends of marine big data in China. My report includes the following 4 parts. First, some general information of big data in China. Second, the development of marine big data. Third, how marine big data is applied. And last, where will marine big data go and what we can do together. The big data of China cover the following 4 parts. First, the big data. Second, government policy supports. Third, province development. Fourth, industries development. First, everyone knows the big data have the characteristics of 5 V's: volume, velocity, variety, veracity, along with the technique development. The big data also develops to 5 V's and 6 V's. The 5 V's means add visualization on the foundation of the 5 V's. The 6 V's means add validity on the foundation of the 5 V's as a new technology. Big data is able to find valuable rules and hidden relationships from massive data, thus identify some important factors and information unknown before. In other words, big data can make the knowledge visible. The concept of a National Big Data Center was proposed in October 2016 through data integration and sharing. The National Big Data Center will promote the integration of technology, business, and all kinds of data to achieve multi-level multi-regional, multi-system, multi-sectoral, and multi-business collaborative management and service. The Chinese government pay high attention to big data. From 2014 to 2017, big data was written in the government reports. From 2013, Shanghai proposed the first big data plan. Then 23 provinces have already published their policy documents. In fields of public administration, manufacturing, electricity, e-commerce, intelligent transportation, finance, scientific research, education, health, telecommunications, and culture. Big data development guidance and planning have also been developed. Through years of efforts, the application of big data in China is developing by leaps and bounds. The second, development of marine big data in China. We make the best of national ocean observation, monitoring, and survey resources, carry out global ocean observation cooperation, establish and improve the three-dimensional marine observation network and data transmission network. For this end, we will strengthen and improve the space-based, outer space-based, shore-based, sea-based, and other means of observation. Expand function of each observation site, establish China's coastal marine environment online monitoring system, implement monitoring on typical ecosystems and gulfs, and establish a comprehensive and systematic marine investigation system. At the same time, promote the construction of deep sea, polar, and ocean observing system to provide a useful complement to the global ocean observing system. Development of marine big data in China includes 5 parts: design of marine information system, construction of marine cloud platform, construction of marine integrated database, research on marine big data standardization, and research on marine data processing and analysis. This is the design of marine information system. NMDS carry out marine data management system research and design is created according to the marine data processing procedure, data types, and other attributes. A hierarchical data management structure is created, including 3 parts: raw data, basic data, and integration data. Raw data includes receiving data and raw data. Basic data is various of marine environmental standard data sets, marine geography and marine thematic information, and all kinds of marine information products. Integration data is data used for analysis and application that is extracted, standardized, and quality assessed from the heterogeneous basic data by using the database cluster technology. The objective of integrated data and basic data traceability and linkage of data are realized. And the construction of a marine cloud platform. On the basis of data resource management system design, NMDS has carried out the construction of a marine cloud computing platform. Cloud platform construction is divided into 6 parts, including border security zone, call exchange area, cloud platform management area, computing resource pool, and a storage resources pool. All 6 parts are independently planned and deployed with server, storage, management software, and virtualization software, corresponding to their functions. Smooth expansion is designed in respective area. And the construction of marine integrated database. The ocean environmental integrated database and marine cloud computing platform is under construction using the mode based on variety of architectures to support multiple applications. This will solve the current data management bottlenecks to promote the marine data management and mining. In general, integrated ocean environment database mainly includes the basic support platform, the database resource platform, the database management platform, and the database service interface. Among them, the basic support platform mainly includes computing resource pool, storage resource pool, and network resource pool. The database resource platform is a core part of the database and uses the platform as a service model to integrate all kinds of data platforms involved in the acquisition, processing, transmission, storage, analysis, and application of various ocean data. Database management aims at a unified management and coordination of resources. The interface of database mainly provides the data management related interface and the marine big data analysis tool to realize the unified management of database sharing service. And the research on marine big data standardization. Research and development of unified data standards and technical specifications are carried out as an MDIS to improve the applications of big data standards, including the hierarchical structure of the marine big data system, the standard composition, and the intrinsic relationship between standards. At present, the ocean data system is composed of 6 basic systems, which are basic common standard, data technology standards, platform and tool standards, management standard, safety management standard, and application standards. These 3 subsystems are interacted, interdependent, and complement to each other. And the research on marine data processing and analysis. We are planning to develop a data source pool for heterogeneous marine data research and development of the technique as big data extraction and transformation, standardization, quality assessment, quality integration, and other processing technology. Meanwhile, we have started to research on and develop marine big data mining technology, providing technical support to marine big data application of all kinds. And the application and the service of marine big data. Application and the service of marine big data includes 4 parts. Marine big data processing and service. Carry out multimodal data acquisition, format transformation, and data classification, quality evaluation, quality of data integration, mining, and application service. These are some examples of marine big data application and service in China. Basic product, marine measured data products, global and regional marine environmental statistical analysis products, marine section statistical analysis products. And MDS has developed a set of marine environmental numerical model, China Ocean Reanalysis, making use of operational observation data, national survey data, and international exchange data to run the numerical model and realize data dissemination and service. Big data technology is used in the development of a sea level assessment system. By analyzing data of sea level change, tides feature, elevation, coast condition, population, economic development, and so on, the proper indicators can be selected to evaluate the vulnerability of sea level rise. The big data technology are applied in the research and the development of oil spill monitoring system, as well as rescue decision system. These systems make full use of marine environmental parameter data, including sea surface wind, air pressure, wave, current, temperature, and salinity, tides and tidal current, and so on, taking into account of marine environmental analysis data, buoy tracking data, satellite data, ship observation data, drifting material features to make comprehensive evaluation on oil spill trajectory and impact areas, search and rescue spot and routes, therefore help to make decisions based on priorities and the development and application of blue economy big data. Using the data in the domain of economic development, social livelihood, environmental ecology, scientific innovation, comprehensive governance, public service, international issues, and cooperation, we designed the China Ocean Development Index in order to reflect the overall development of ocean economy and ocean issues in a quantitative way. We also designed the China Ocean Economic Development Index, Marine Economy Climate Index Report, and the Blue 100 Marine Economy Stocks Price Index as well. And the big data of marine ecological, spatial planning and management. Using the data in the domain of economic development, based on big data of marine ecosystem, marine environment, ocean resources, ocean economy, sea use, SOA has carried out the marine spatial planning at the national, provincial, city, and county level. Basically, Chinese MSP contains two types. One is marine major function-oriented zone planning. The other is marine functional zoning. Tomorrow, my colleague, Dr. Lu, will give you more detailed information about China's MSP and blue economic. The first picture you can see in the slide is about research outputs of China's provincial marine function zone. NMDS has actually been in charge of establishing the standard of marine function zoning, and every coastal province in China has its own marine functional zoning plan. The lower part of this slide are provincial marine major function-oriented zone plans of 3 coastal provinces, which are Jiangsu, Fujian, and Tianjin. And the big data of sea area and iceland management. China actually attaches great importance to marine integrated management by applying marine big data. In 2015, SOA released Marine Ecological Civilization Construction Plan, which introduced measures for strengthening ecological conservation and pursuing green development. SOA has established sea use monitoring system, Iceland's utilization monitoring system, and marine environment monitoring system in China. The left bottom image in this slide is National Ocean Environmental Monitoring System of China. The right bottom image is National Sea Use and Ice Use and Iceland Utilization Monitoring System of China. By these systems, we can get a huge amount of data with different types from our ocean. These data, along with other types of ocean data, like ocean economic data, social data, etc., could help us to set our red line for the protection of ecological regions in order to better protect our ocean. The first picture in this slide shows the red line for protection of ecological regions in Bohai Sea. Red line for the protection of ecological regions, along with marine functional zoning, marine major function oriented zoning, help us to achieve our goal of marine integrated management based on ecosystem. Through a number of international and regional programs, marine big data and data products are providing service regional and globally. CMOC China carry out a dataset mirroring with other international or national nodes, provide integrated marine environmental data set for users domestic and abroad, develop big data technology, communication and data sharing, cooperate on marine big data application. Odin Westpac integrate marine data and information in the Western Pacific region, provide user-oriented service for Westpac members. IOI China, Regional Center for the Western Pacific region, provide data management training program for the Westpac region. We also have other data centers that provide big data service worldwide, like the China Asian Big Data Center, China Argo Data Center, Ocean Data Portal Westpac node, and so on. And the last, the future of marine big data. China Marine Big Data Center is built on the centralized and distribution concept. It will integrate existing storage and computing facilities to put the demand, customization, and expansion capabilities into reality. Make use of virtualization technology. The Big Data Center will establish an open marine cloud computing platform which is safe and with an unified standards. Through the construction of CMOC China, China Marine Big Data is planning to establish major protocols and mechanisms by means of the technology such as data mirror, database mirror, database synchronous to ensure the data center and international related NODC data sharing and information interoperability. We would love to actively explore cooperation opportunities between China and the EU on Marine Big Data Center to carry out dataset mirroring, data sharing and exchange, and the framework of the Big Data Center, technical research and cooperation on blue economy, marine environmental protection, sea level change impact, ocean and coastal management would be developed to enhance the marine informatization levels of both China and the European Union and members. This is my report about the status and the trends of marine big data in China. Thank you for your attention.
Thank you very much. Now open to the question or comments for this three presentation. Any question? Or please.
That was all very fascinating. For the last presentation, there was this talk of the ASEAN Data Center, and there was also, you mentioned open data as a principle, and this is, of course, the principle that we're working on, and also the Copernicus project we're working on. Do you have data sharing agreements with all the Philippines and Vietnam, etc., in the framework of this ASEAN cooperation?
Okay. Wenxi, can you answer this question about it?
Right. Okay, it's a very good question. Yes, the openness and sharing of the data would be actually the trend. In my presentation, I actually raised a question. I said nowadays the accessibility of ocean data is actually quite hard. It is very hard for one single country to get access to all the data. So data accessibility and sharing is actually a very important element. In the previous presentation, in Dr. Wang Hui's presentation, we said that China has been involved in many international cooperation. We've we have launched 300 Argo floating devices, and we have collected data in the South Asian Sea. We've also collected data on tsunami, and we shared it with our neighboring countries, in particular those southeastern countries, including those ASEAN countries. Yes, we do have cooperation with ASEAN countries under this framework. My suggestion is, in the future, when we work with the EU, perhaps we could work out a system for information sharing, because data sharing is the natural requirement for marine disaster prevention and for ocean affairs management, but it's also subject to policies and administrative regulations. So my suggestion would be, in the future, perhaps both parties could set up a scheme to share data by using existing data, for instance, data mining, big data, big database. Because, as I said, on my slide I have 6 V, and one of the V is actually about data composition. So, I mean, in any way, once we have set up a scheme to use big data without jeopardizing any party's IPR, then perhaps it's beneficial to end users, in particular in the areas of science and research in disaster management. So that would be my advice.
Comments? Please.
Microphone, please. Microphone.
Okay. I'd like to thank you for the presentation, and I have some questions regarding the tsunami that you mentioned before. I'm wondering if there is any warning system in the area, not only in China, but actually in adjacent countries, And in case that they have a real tsunami, that you can forecast the propagation of the tsunami, the area that is going to be affected by the tsunami, and if there is a contingency plan to protect the people. Additional, I have to ask you if there is, if the model can simulate the inundation of the water. That means how the water climbs on the surface. So it is very, very important to understand the behavior of the tsunami also on the land. Thank you.
Okay, thank you for the question. About the tsunami, the service in China, like MFC, yeah, in fact, it's only when the center has the ability to make the tsunami warning service. This follows the 2004, the Indonesia, the biggest tsunami, the hazard. So from that, China started to build the tsunami, the service the system. We provide the service. The parallel is two aspects. One is the Chinese coast area for provide the local government, and the other is the international service. Just I mentioned South China Sea tsunami center is get the permission from the IOC headquarters. You know, the tsunami warning system is based on the earthquake station. I mentioned we collect over 500 such stations. That means in my center we have ability to judge the earthquake, but we don't know, we don't provide to the public about the earthquake. That's another agency, the China agency. We just use this system following to start the tsunami service, like the New Zealand. Last year, the New Zealand earthquake, totally we use 15 minutes, 5 minutes to get the judges the earthquake, sea flows, earthquake, 10 minutes to finish the first list the information to the public. At the moment, SOA with earthquake administration, we have a data share policy. SOA, we have a very few seismic stations, totally 25, but we get another 58 from the Chinese earthquake administration. Also, we have the data sharing with the South China Sea surrounding the country, like the 5 stations with tie the gauges data. So it's very important. I think it's, also use tsunami, the buoy in the South China Sea. In the near future, we try to send another 1 or 2 tsunami warning buoy system in the Northwest Pacific Ocean. So it's I think it's challenging work. We can we still continue to do some of the work. The main in the past several years is a very tight link with the international community. It's a sub-region with the PTWC, Pacific Tsunami Warning System. So that's your question. Answer your question?
Yes, I understand. I understand that this is to describe or to simulate the tsunami, it is not just only a local subject. But just to give you an example for the Mediterranean, if a tsunami comes to Italy, it's nice to simulate and to understand that other countries like Greece or whatever, Cyprus is going to be affected here and there. So the warning system is not just only for China. I'm expecting the warning system to be to include other countries too, in case that somewhere else comes the tsunami, to be protected the people. That's the main concept of the warning system.
To get the quickly response, we need to build the data bank to get the quickly, like the Mediterranean Sea is very shallow, the continental shelf, so the warning time is very, very short. So, okay, we develop some of the tsunami model. It's about our center, all scientists. We can share the experience. Okay, thank you very much.
My question is about the coupling with the river modeling. I saw, and I saw you have a very nice and important coastal high-resolution forecasting system for storm surge. So how do you foresee the coupling with the river modeling?
Dr. Guimei Liu can try.
Yeah, for storm surge and in general.
Like a storm surge, the company tied with a wave and including the flood, and you can introduce some of the basic situation.
Sorry for that, in fact, because my major in my degree is only do the temperature salinity and OSBO research and rescue and ecosystem. For the storm surge forecasting, is belong to another division. So I'm not quite sure on the technological detail what they have done for that. I just know right now they based in some for the storm surge forecasting, we just maybe not use the coupled model to do the forecast, because they have done some experiment. It seems to use the coupled model, it will take a long time for the forecast, and also for the accuracy, it can increase, but maybe not as we expected. So it's just under research status right now.
It's a little bit of difference, but for the regular storm surge, it's use regular model window forecasting system to get the different stations water level. Yeah, how much is the storm surge is very quickly to judge. This is not the company, but for the to judge over the dam. Yeah, recent year we developed the operational full company the model. Use this is a company many with wave and storm surge with flooding the upper river. It's very new. It's Guimei Liu mentioned is just 2 or 3 years. We have many the experiment. Yeah, it's a good performance like the East China coast area like Fujian province. We separate 4 regions to get the high resolution. It's challenging to install the field measurement, how to record the typical process, is the severe weather the condition to get the picture. Yeah, it's very challenging. Yeah.
You might have remembered from Jan Bart's presentation on eModNet that we got very good improvement in the storm surge modelling when the bathymetric resolution was improved. This was the UK Met Office found really huge improvements. They called it massive. We have difficulties in the EU in trying to convince the authorities to do more surveys in the near coastal areas that would improve the storm surging even further. What sort of resolution do you have in China, and do you have a mapping program for these near coastal areas? A survey program?
Okay. Yeah, you're right. It's very important to get a very high resolution bathymetry. Normally, we get such data from like another Chinese agency, the survey agency. Like we have a ongoing project with Hainan Island. We get such data from other agency. Sometimes Chinese research vessel, we bring some of the measurement. I don't how to say the name. 这个侧身这个高，特别对。
The multi-beam, they will use multi-beam, but they will use multi-beam line to check the water depth, to measure the water depth.
Multi-beam
by yourself.
I get from the translation.
多波数，这一个多波数侧身仪，对。但是大多数时候呢
But most of the time we still get data from other institute. So sometimes we can get the data from research vessels.
Yeah, it's about the resolution of the bathymetry when you use. What do you feel? Because you have a multi-scale forecasting systems from Northwest Pacific and then finally to very small bay. So in such a way, you need different bathymetries with different resolution. I would like to know the resolution of the bathymetry you could get in China from other agencies.
I cannot say exactly such the data, the high resolution. I think it can solve the our forecast, build the forecast system like 10 meter to 20 meter, such storm surge complement model. It's okay, but we try to for the next step, if we build the much more high resolution, that's need the challenge. Not maybe it's not available. I think it's 就是这个。
The exact scale or resolution, we're talking about the exact resolution or the scale for the coastal map. It's difficult for me to tell you on the top of my head. I don't have exact figure. But at the moment, we can cover probably 10 meter to 20 meters. We can use storm couple models in those cases we should have enough resolution, but again we cannot just get data ourselves. Again, we have to get the data from another authority. To build a high-resolution storm model is a very specific request.
Comment for that. In fact, for the real coastal region, we have high resolution. Not all the regions, but some small region. We get those data. We have to pay to another agency for those data. If we focus on projects such as for the Daya Bay, then we have this project, then we have the fund to support those data, then we buy from those another agency to get those data, but only for the really very coastal region, very small region to get those data. In those data, some region, not all the region, we can have 50 meter or 30 meter, some resolution like that. But for the regional forecasting system, it's about, I think, only in kilometer resolution we can get for the topography.
Then it's a global.
For the global, it's, I think it's 1 minute, it's open and anyone can get it. Yeah.
Okay. Yeah, please.
Something happens, okay. If I have the time for one more question, I would like to go to the operational forecasting services in China. And actually, I'm impressed of all these activities that you are having there. And actually, I go to the data simulation part, where you have implemented the optimal interpolation. And actually, I noticed that after 5 days, the error increased extremely, about 89%. Initially, it was something like 25, 23%. I think that, for my opinion, it is not a problem mainly with the data simulation, the one that I saw, okay? But actually, what I think it is that maybe the model that is implemented needs further tuning, because actually, the model forgets the information provided by the observations, and afterwards is doing what it has to do. That's why it increases the error significantly. And this is maybe it's a serious problem that you may face later. That's all my comment, about that. Thank you.
Oh, sorry for that. Thanks for the comments. In fact, right now we use two methods. One is ENOI, another is 3D1. The 3D1 method is by cooperation. Is our Italian members, and then we learn from them, and we found it's really powerful to use this method into our system. Originally, we use Ensemble OI. So right now we are trying. We need to compare these two methods and then evaluate it. Which one is much better? Because we need to find a kind of balance. One is improve our accuracy, forecasting accuracy, and also we need to save our computer time. In fact, in our center, the computer time is really fully used, and we have to consider that maybe after several years we need to encourage that, because we have another new project which can provide us to increasing our. We will establish a new high supercomputer. Then we maybe needn't consider too much on that, but at least I think we still need to evaluate better and which method is good, and another one, try to find the best one. Thank you.
Also, just to mention that even in 3D VAR, the most important part is to assess the error covariance. That is very, very difficult in some cases. In case that you have a nice error covariance, then the story is simple. It works well. It works nice. But even though, if the model is not appropriate, has some biases, again, you will face the same problem. But that's just only for the discussion. Okay. Thank you very much.
Yeah.
For the observation data and how to into the model, we use data simulation is very very important. Combination with observation work data and plus the data simulation technology. I find that this year in Italy, September, Goudet Oceanville will host a joint workshop observation task team and data simulation and task team joint workshop is very important to improve global and regional forecast system. Thank you very much. Okay, time is okay. 10 minutes is over. Thank you very much. Thank you everybody, and thank you this afternoon speaker. All the speaker make the great contribution to this afternoon the meeting. Tomorrow morning session will start at 9 p.m. We see you tomorrow morning. Yeah, thank you very much.
It looks to me like we are getting bigger. Because we were Italy and China, now we're Europe and China. So it's very good. I feel it very positive. Thank you very much.
Shall we